I don't know. I don't know what you said there, but we're moving on. Okay, rational roots. So yesterday we did this factoring of special cubics because we wanted to solve equations with x cubed in them, and we didn't have a perfect way of doing it until yesterday. So now we're going to try to factor and solve polynomials, third degree, fourth degree, fifth degree polynomials when they're not perfect cubes. And we can't do any easy factoring. We're going to do essentially some hard factoring. So let's look at, I'll do this one. X cubed plus x squared minus 3x minus 3. And I'd like to be able to factor this one because I want to solve it for being equal to 0. Now, when I'm factoring, I'm looking for roots. I'm looking for when this equation is equal to 0. I'm looking for when the polynomial y equals x cubed plus x squared minus 3x minus 3, when that touches the x-axis, or even where it doesn't if I'm getting complex roots. And so when I do that, I want to try to factor this thing because that's the easiest way to find these roots is by factoring. So if I want to find factors, I need to look for what's called my rational roots. Now, why am I looking for rational roots? Because if I factored something like, now this is going to be an aside here because this isn't this problem. If I gave you a problem like x plus 1 times x minus 1 times 2x plus 5 equals 0, you could solve this one quite easily. X equals -1, x equals +1, and x equals -5 halves. I do that one kind of quickly, but maybe you'll see the pattern. And each one of these answers here is a rational number for a root. Rational numbers are fractions, positive and negative whole numbers, but they're not things like square root of 3. Okay, that's an irrational root. That's an irrational number. So I'm going to look for the easy ones, the rational ones. Okay, so here's how we're going to try to find them. Different than the rational root theorem that I did. Oops. There you go. A little earlier today. Is there a way to what? No, that's the Snagit program recording it. I know. I'm sorry. I kind of don't like it either, but it's. I'll look and see if there's a way I can have it show in a different way. But I haven't. All right. So, got my calculator coming up here rather slowly. We're going to put that x cubed plus x squared minus 3x minus 3 in the y equals screen. And that isn't what I have in the y equals screen, so give me a minute for my calculator to come up. Sorry, I started this without my calculator up. Taking its time. Okay. But, you know, I like it. I move at such a slow speed, everybody's able to keep up with me. Okay, so I'll go to y equals. I wanted large screen. I keep telling you, oh, I hate that. Okay, here we go. I'll go to my y equals, and that equation that I gave you before was x to the third power plus x squared minus 3x minus 3. Okay? So if I'm going to go find the roots of this equation, I want to find where this cubic touches the x-axis. All right, so I'm going to just do a zoom number 6. And I'm going to just, by inspection, see if I can find any places where this cubic is touching the x-axis. And where do you think you see it's touching the x-axis? -1. And then kind of 2. Yeah, so that kind of 2 may not be a rational number. But boy, that -1 probably is. Okay, so I can, let's see, does it find the root if I do it this way? I can use my calculator to test out that -1. I think that's -1. And so I'll do second calc. We'll do the 0. Left bound. Oh, sorry, second trace. Left bound, get to the left of that point. I did 0 on this one. And my right bound, use the right arrows. The left bound was, can you see where I'm pointing to? That, somewhere over here is going to be to the left. Okay, and then use your arrows to get your to get the crosshairs to go up over the axis. And then that'll be your right bound. Hit enter. Guess, just hit enter. Oh, it gave me a 0 at -1.732. That doesn't seem like it's gonna. Okay, so there's 2 roots sitting here, which somebody said, I heard somebody say it's crossing the x-axis twice. So let me see if I can find one that's at a better number, like an integer, or maybe like 1/2 or something like that. So let me run that one more time. Yes, it's going up, over, and back down. Hate when it does that. So my 0, I'm going to leave that as my left bound. And then I'm going to move back over, make sure I'm to the right of the curve there, and see if it finds it for me. -1. Found a rational root. That's as much as we're going to go to just finding rational roots. So when your homework problem says find a rational root, we found one at x equals -1. Your homework problem says to find all possible rational roots. We're not going to do that. That's the rational root theorem. It's just way too much work. So we'll just go looking for one. Okay, you're going to be doing good if you can find 1 or maybe 2 rational roots. Yes, sir? You usually want to be on the other side of the axis. Okay, so if you just cross the axis, you're usually going to get to the right bound. There are other ways of finding this on your calculator. The other way would be to hit second graph table. And I have mine set in a different format. I have mine set in the ask, which we're going to do here. We may do in a minute here. We'll see. We go back to the auto. And if I scroll up a little bit, I see at -1, the y1 is 0. So that tells me that there is a root there. Okay, so that's a couple of ways to get a rational root. The other way of using the rational root theorem is just unwieldy. Okay, so problems 1 through 4 on your homework, that's all you're going to need to do. Play around with the calculator a little bit. Okay, find the rational roots. All right, now we'll get to the fun part. We'll try to do a few of these. Okay,